Okay, welcome to part 2 of day 1 2021. This part I will not read the whole exercise now, but this part is saying that essentially we have window of 3 values, consecutive values, and we do not compare just a value with the previous one, but the sum of the values in a window of 3 elements with the sum of the value of the window of 3 elements that were just before. So this is an example. At the third line you have a window of 3 elements, and the sum of 199, 200, 208 is the value of this window. And the next line, you again can build a window of 3 elements, which includes the current element and the past 2. So you have basically the first element of the window A is left out, and you compare the sum of these 3 elements with the sum of these 3. And then you compare the sum of these 3 elements with the sum of these 3, and so on. Now, an important thing to notice is that at any time you have only 4 elements that you care about, which are this, and this. So basically, at any point in time, what you care are the last 4 values. And what you do when we do the sum of these 3 values and the sum of these 3 is just taking different calculations based on the 4 values that we just read. So basically what we have to do is actually to just keep track of the last 4 values in their order, and then we have to do some comparison and sums between them. And every time we find the configuration that we care about, we count the increase. So let's go to our editor. This time, instead of part 1, we left part 2 that we want to run. And this time, again, we say def part 2, and I just copy shamelessly the reading code of the first exercise. So I just read again. Could be nice to have an helper to read the file every time, but really it depends on the exercise, so I don't worry about it at the moment. And I want again to iterate over the lines in this file. For line in fr, what I do, I have 4 values, so I just call them a, b, c, d. I create them before iterating, of course, and Python has a nice way to define multiple values in a single shot, which is using tuples. So say a, b, c, d are equal to what? At the beginning they're empty, so I say none, 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 and none. Then every time I see a line, what happens is, first of all I want to check, I just want to put the value that we just read, which is the current value, which is int of line. In fact, I will copy the code to handle the empty line also from here. And what we want to do is to reassign the values in order to put our current value in there. So what I say is a, b, c, d is equal to b, because b becomes the new a, so everything is shifted, so b, c, d, and current value. So this may require some explanation. What we're doing is we assign 4 interesting, so we assign 4 values to none. These 4 values are the 4 values that we are observing at any point in time, which are basically the 4 lines that we are reading. So if we are here, the 4 values will be in this, and this, but these 2 values are in the same window, so we actually only care about the first 4 values. In this case, 199, 200, 208, 210. What we want to do is to keep track of the 4 values and them in variables, so that we can do all the comparisons we want. So what we do is, first we initialize the 4 values before reading anything, 4 times the value none. Then we just say, okay, this, once you read a line, you know that this line is not empty, and we convert it to an actual integer. We reassign these 4 values to basically shift of 1. So we say that A, B, C, D are equal to B, C, D, and the current value. The current value is the latest one that we add. Now we want to do the comparison, but before doing the comparison, we need to be sure that what we're seeing is a complete window, because the comparison starts only when we are at the fourth line, at the line 4. So we need to be sure that A, B, C, and D are all not none. How do we do that? Well, we know that these values are shifted, so the only case in which they can be none is when A is none, because A is the oldest value, the line that is the first one in the window of 4 elements that we want to check. So if A is none, continue. So we say, okay, when you just find that A is none, means that we still didn't observe all 4 values, and we continue. We do not have to check all of them, because A is the oldest value, and if A is not none, we are sure that we read already 4 values. Fine, so now we have to write the condition. The condition, which is the thing to check about these 4 values. Let's see again the description of the problem. It's asking us to take the sum of the first 3, the sum of the second, third, and fourth at any point, and see when there is an increase, which means in our case that B plus C plus D is greater than A plus B plus C. Let me check a bit if this is correct. Yes. This is actually a bit strange as a condition, because if you... this already should work, but this B value and this C values are actually in common. So what you're doing is checking whether D is greater than A. This is just high school arithmetic. It's just an equation. So if you have a value that is in both sides of the comparison, you can just ignore it because it's a sum. So it doesn't change at all the situation. What you're asking actually is if D is greater than A. Now what we do is we want to count the increases. So we also create a variable called increases, which is 0 initially. And if this happens, we say increases is increased by 1. Not a mouthful, but okay. So increases is increased by 1, and at the end of everything we just return increases, and that's it. This should be it. Will it work? We can only check. 1608 is my solution. 1608, and is correct. Let's see a bit if there is something that is a bit confusing. So first of all, I focused on the problem. So I say that I want to compare a window of 3 elements with the next window of 3 elements, but 2 of the elements overlap. So determining if a window like A and a window like B are one greater than the other means basically to take the last 4 elements and see if the sum of the first 3 is greater or not than the sum of the last 3, which is basically the second, the third, and the fourth. So the whole problem is based on sliding through this list of numbers and every time comparing the last 4s. But I do the comparison only after the first 3. That's why I have this this condition on A is none, because if A is none, we say that A, B, C, D are the values in order. If A is none, I know that I don't not have a full window. Why I check A? Because it's the first of the window, so it's the oldest element, the first one, the one that is on the top on the last 4. So A is what actually tells me if I already have a full window. The other values are just numbers. Then I have to compare the 2 windows. So in this case, for example, B and A or C and D. How do I do the comparison? I have to take the sum of the first three elements on the window, for example, this, and this, and the sum of the last three elements of the window, this, and this. Since we call these numbers a, b, c, d, this is a plus b plus c greater or lower than b plus c plus d. But this condition can be simplified in a greater than c, greater than d. Sorry, these letters are confusing. So this comparison, so basically to do the comparison, I only need the difference between the first element of the previous window and the last element of this window, which are a and d in my case. And the rest is the same logic as the first part. So I just keep track of how many times d and a, which are the four values that are before the current one, have increases or decreases. And that's it for today.